Okay, so welcome back to our second video on completing the square. Again, we're still sticking with monics, okay, so the coefficient of the x squared being 1. What we're going to do is, just like in the last video, we're going to complete the square on this parabola, okay, to find the coordinates of the vertex, okay, and we're also going to find the x-intercepts and the y-intercepts, and then we're going to graph it, okay? So, just a reminder as to why we're actually completing the square here, right? The reason why we're completing the square is because this is in general form, and we're trying to take it from general form into vertex form, okay, to read the coordinates of the vertex more easily, okay, rather than what we're doing here, because it's really hard to find the coordinates of the vertex here just at the moment, okay? And also I'm going to show you an alternate way that we can also find the coordinates of the vertex, which comes from completing the square. So, let's dive on in. Okay, now what we're going to do is, when we're completing the square, we're trying to make this expression here have a perfect square in it. That's our whole idea here. Right, so you remember last time what we were doing to complete the square is that we were adding on half of the coefficient of x. Okay, so half of the coefficient of x, which is 3 divided by 2, squared to both sides. Now there's no easy way to simplify this fraction. That's the simplified form as we can get it. So, we're going to complete the square. So that means we're going to add this on, yeah? Okay, so y is equal to x squared minus 3x. Now we're going to add on the 3 over 2 squared, but we don't want to modify this equation. So whatever we add on, we have to take off, okay? So we minus 3 over 2 squared as well. And the reason why we do that is because these two terms here, they essentially become 0, okay? And we still have our plus 4 that we haven't done anything with just yet. Okay, righto. So essentially, what we've just done is this part of our expression here becomes our perfect square, and I'll explain to you what happens, okay? Remember last video I told you for this to become a perfect square, when we're putting it into perfect square form, okay, our x goes in, because we're talking about our x variable, the sign of the coefficient of x goes in, so it becomes a minus, and whatever is in this bracket here, okay, whatever's in this bracket also goes in. So 3 over 2, all squared. Right, now what we need to do is we just need to deal with this minus 3 over 2 squared and the plus 4. So let's simplify this out a little bit. If we're squaring this fraction, we square the top and square the bottom. Okay, so minus 3 all squared is 9 over 2 all squared is 4 plus 4. Okay? Alright, now we can't add these two together, so you can either get a calculator at this point and jump on in, or you can work it out in your head. So I'm going to work it out in my head. X minus 3 over 2 all squared. We need this to be on the same denominator, so we have to multiply this by 4 and divide by 4. Okay, so what we do to the top, we do to the bottom. Okay, so now we have minus 9 over 4 plus 4 times 4 is 16 over 4, and we haven't modified our equation at all just yet. Okay. Right, now because they're on the same denominator we can work with them, we end up with y is equal to x minus 3 on 2 all squared, minus 9 on 4 plus 16 on 4 is equal to 7 on 4. So I'm just going to move this up so you can see what we're doing, right? This is where we wanted to get to. We wanted to complete the square to get to this point here, okay? Now the reason why is because this is really easy to read the coordinates of the vertex. So our vertex in this particular case is the opposite of what's in this bracket, so what makes that bracket 0, and that's positive 3 on 2. Okay, and in this particular case it is a y value as well, so it's the same as what our y value is on the outside, so that is 7 on 4. So you'll see immediately, whenever we were doing our last examples, we were getting nice whole numbers to work with, and that's because the number in the middle of our parabola, our x coefficient, was even. It was easily divided by 2. So whenever it's odd, we're going to end up with some fractions. Okay, the process is the same, we just have to deal with a little bit of fractions. Okay, that's the only thing that's a little bit different. Alright, so we found the coordinates of the vertex, now we need to find the x-intercepts and the y-intercepts. So, to find our y-intercept, so to find y, we let our x equal 0. Alright, so therefore we now have y is equal to 0 squared minus 3 times 0 plus 4. That's 0, 0 plus 0, plus 4, our final answer for our y-intercept is going to be equal to positive 4. Okay, so to find our x-intercepts, well, we should really check using the discriminant to see how many we actually have, okay, before we start delving in too deeply into everything that we're going to do. Okay, so to do that, we're going to use the discriminant. So check our discriminant, our b squared minus 4ac. Now our b, our a and our c all come from our original equation, remember? So our a is 1, our b is minus 3, and our c is 4. So come back down here, our a is equal to 1, b is equal to minus 3, and our c is equal to 4. So substituting that in, we end up with b squared minus 3 all squared minus 4 times a, which is 1, times c, which is 4. Okay? Minus 3 all squared becomes 9, and minus 4 times 4 is minus 16. Okay? And 9 minus 16 is equal to minus 7. So that is our discriminant. Now, remember, if our discriminant is less than 0, right, we can say that there are no solutions. So that means it does not touch the x-axis. Okay? So there's no x-intercepts. Alright? Because our discriminant is less than 0. Negative 7 is less than 0. And finally, we always want to check, is it a happy or sad parabola? It's a positive out the front of the x squared, therefore we have a happy parabola. Okay? So, let's use this now, all of this information that we've just generated, to try and graph it. Okay, so we're going to use our information that we found before with our coordinates of our vertex, our y-intercept, and our x-intercept to graph our parabola over here. Okay, so our coordinates of our vertex were 3 over 2, which is 1.5 as a decimal, okay, on the x value. Okay, so 1.5 roughly, and then 7 over 4 is actually equal to 1.75. Okay, just to give you guys a bit of a sense of scale for everything that we're doing here. Okay, so that's going to be the coordinates of our vertex at 3 over 2 and 7 over 4. You're not always going to get nice decimals like that, just giving you a bit of an idea of your sense of scale that we can use. Your y-intercept is going to happen all the way up here, we'll say here at 4, okay, all the way up here. Okay, and we're going to use this information now because we don't have any x-intercepts, and we know it's a positive parabola, so it's going to be facing up, to graph our parabola. Okay, so we know that it's going to come through here at 4. Okay, very, very carefully drawing our parabola now. Alright, it's going to touch at the vertex, which is its turning point, and then it's going to continue on its merry way out the other side. Okay, so that is the graph of our parabola that we have here. So that is y equals x squared minus 3x plus 4. Okay, so all we found was the coordinates of the vertex by completing the square. Okay, the y-intercept and the x-intercept. Okay, there is another way to find the coordinates of the vertex, okay, and it comes from completing the square, and I'll show you more on this a little bit later on. Okay, it won't be today. So, let's get stuck into it. Okay, so the other way of finding the coordinates of the vertex is by realizing that we can use the formula for the axis of symmetry, which comes from completing the square. Okay, again, I'll show you this a little bit later on, but some of you might find this a little bit easier to do. Alright, but when we talk about our axis of symmetry, I've talked about it a little bit before, but it is basically the imaginary line that goes straight down our parabola, okay, that makes it perfectly symmetrical on either side. And it occurs at the place at our exact x value for our vertex. So this gets us our x value, okay, it doesn't get us our y value, but it gets us this vertical line here happening, alright, directly in the center of our parabola, okay? And it's really easy to find. It's negative b over 2a, and this b and this a refers to our coefficients of our equation. So our a is equal to 1, our b is equal to minus 3, and our c is equal to 4. We're not going to use the c in this particular point, but it's always handy to have it written down. Okay, so to find the axis of symmetry, I'm just going to bring this up a little bit, we're just going to substitute in our values. So our x is equal to minus 3 on 2 times our a, alright, just by substituting in. Minus and a minus make a positive, so we now have 3 on 2. That is our x value for our vertex. If you remember from when we were doing this just a moment ago, the coordinates of our vertex were 3 on 2 and 7 on 4. I'm going to show you that we're going to get the second value. Okay? So to get this second value, the y value, we need to take this x value and substitute it back into our original equation. That's going to get it where our y value is on that curve when x equals that particular thing. Okay, so just remember, right, what we're essentially finding is the y value here when x is equal to 3 on 2. Okay, that's the whole idea behind it. So we're going to substitute it all back in. Okay, so I write sub x equals 3 on 2, right, to find y. So therefore my y is equal to, using our original equation here, is equal to 3 on 2, wherever we see an x we replace it with 3 on 2 now, minus 3 outside of 3 on 2 plus 4. Okay, so now let's have a bit of a play around with our fractions and get it all working. Okay, this again is a little bit of an easier method. Okay, we can just use our calculator at this point, alright, but sometimes it's good to practice our mental arithmetic. 3 on 2 squared, well, we could square the top, square the bottom, so that's 9 over 4. Okay, 3 squared is 9, 2 squared is 4. Minus, well, 3 times 3 over 2, we only multiply the top numbers together. Okay, so that becomes minus 9 over 2 plus 4. None of these fractions are on the same thing. So I need to get this onto 4. Okay, so I need to modify 2. Okay, and to do that I need to multiply by 2 to get to 4. Okay, what I do to the bottom I do to the top, times by 2. And I also need to multiply this by 4 and divide this by 4, okay, to get everything as a fraction. Alright, so we've talked a little bit about this method before. Again, you can just use a calculator. I'm just doing this to show you how you might do it if you don't have one. So now we have 9 over 4. Minus 9 times 2 is minus 18 over 4, 2 times 2, plus 16 over 4. Now what's going to happen when you add all of these things together, okay, 9 minus 18 is minus 9, plus 16 is 7, okay, which is equal to 7 on 4. So that is the y value at the axis of symmetry. So you'll notice now that's exactly what we wanted, because at the axis of symmetry we get the x coordinate of 3 on 2 and the y coordinate of 7 on 4, which is exactly what we ended up with last time, okay, without completing the square. So that's just another way of doing it, okay, just so you can see that there are multiple ways of doing this thing, okay, but it depends on what the question asks you, okay, just be careful with that. Hope it helps, okay, and have a good day.